Hi class. In this and the next video lecture, we're going to be addressing a couple very important and fundamental science skills. The skills that we will be addressing in this lecture will be twofold. One of them will be constructing graphs, specifically graphs that have x, y axes. So those are your typical coordinate graphs where you will plot data and whatnot. And the second skill, just equally as important, if not more important, and especially important on the AP exam or on any kind of standardized test that has a science section, is interpreting graphs. All right, being able to look at data plotted graphically and interpret what it's trying to tell you. The key here is that most graphs are trying to tell you some kind of story, and we have to be able to interpret that story using our critical thinking skills. So I would like to think that this lecture provides you with some kind of foolproof guidelines for creating easy to interpret graphs. And if you can create easy to interpret graphs, then you should also probably be able to interpret graphs as well. So being able to construct graphs will help you in your graph interpretation. Before we learn about constructing graphs, I think it's important to know, and I have to imagine that most of us are aware, that there are many different kinds of graphs. For example, we see a typical line graph. Over here we see a typical bar graph, and this bar graph in particular has many bars at any given treatment or year, for example. And we'll revisit these graphs as well. Here we see a pie chart or a pie graph. Above here we'll see a graph known as a histogram. We may not be familiar with histograms just yet, but we will start to get into what a histogram is and what it tries to tell us. And finally, what we see, this graph has a few names, this last one. First of all, this is the histogram. And this last one over here is known as, its official name is a regression curve. Okay, we'll talk more about that. But we can also describe it as, and forgive me for writing over the graph, we can call it a line of best fit. Okay, that is a line of best fit where we have some kind of distribution of data, and we try to provide a line that best fits that data. So the data is trying to tell us that there's a trend that exists, and so our line of best fit, or our regression curve, tries to best interpret those data. Needless to say, every graph that you use has its purpose. For example, many times a line graph will show you some kind of trend, upward or downward. A bar graph shows you differences in magnitude between different treatments. Pie charts, for example, show you relative proportions compared to a whole. Histograms will show you distribution among a population and the relative abundance of that distribution in that population. And like we said, a line of best fit indicates some kind of trend in a varied pool of data. As scientists, it's important to know what all of these graphs are used for, how to use them, and how to construct them. And every situation in which you need to graphically display data calls for a specific and a particular kind of graph. As we move forward in this class, we will begin to become familiar when certain graphs are appropriate and when others are appropriate. For the purposes of this lecture, however, we're going to focus on graphs with two axes. That is to say, graphs like line graphs, bar graphs, histograms, or regression curves. All of these graphs have two axes. We've got our y-axis, and we've got our x-axis. Those are the graphs we're looking at. So really we're just sort of ignoring pie charts for now, but we can come back to that at a later date. Graphs with two axes need at least 6 and maybe 7 different criteria to be a good quality graph. The first criteria is a title. Okay, and we're going to talk about what makes a good title. Secondly, its axes need to be labeled. We will talk about this again, but the independent variable needs to be on the x-axis. The dependent variable needs to be on the y-axis. That goes 100% of the time. The best way to think about it is the acronym DRY mix. All right, D is dependent, R is the responding variable, and Y is the y-axis. M is the manipulated variable, or I is the independent variable. So that is saying the same thing. The manipulated variable is the independent variable. And the X suggests it goes on the x-axis. All right, the third quality of a good quality graph is that the axes are evenly scaled. Okay, that means two things. Number one, your graph doesn't only take up a little bit of the graphical space. That is to say, we want our graph to take up most of the graph. All right, so it is easy to interpret and easy to read. But more importantly, or equally importantly, that each axis increases in consistent intervals. For example, if I go by ones and for a bit, I cannot just all of a sudden jump to 9. All right, that would not be an equal interval. If we're going by ones, we have to stay consistent with going intervals of ones. Okay, that's what axes evenly scaled means. All right. Fourthly, our units on our axes need to be included. That is to say, if we're measuring time, you have to tell me that we're measuring in seconds. Or if we're measuring in centimeters, tell me that. Tell me centimeters is the unit of measurement. If you don't tell me the unit of measurement, I can't assume that you're measuring in any particular unit. Fifthly, and this is somewhat unusual or at least counterintuitive, but our graph does not speak for itself. As scientific authors, we need to be telling the reader what our graph says. That is to say, we need to be interpreting our own graph, and we do so in a caption that explains what the graph is trying to say. And that caption goes underneath a graph, and we'll talk about that more. Sixthly, this goes without saying, but the proper data needs to be plotted. You can't just give me good axes, but I would actually prefer to see proper and accurate data plotted on your graph. And finally, this doesn't necessarily have to happen, but if necessary, you should have a key or legend that indicates maybe one line or one bar if it's color-coded or something to that effect. And we'll talk about that more as well. These are the qualities that every good graph needs to display. If you're missing some, your graph is not a quality graph, you'll probably lose some points. Your graph will be less interpretable than preferred. All right, what we see here is an example of a quality graph. It displays all 7, well actually 6 of the qualities that we just described. It does not possess it does not possess a key or legend, but it doesn't need to. So it possesses 6 of the 7, but it is a good quality graph. First of all, we see a title. Notice that the title starts with the words "the effect of." Your title or your titles of your graphs will always start with the word "the effect of," and you'll see that this cigarette consumption is the independent variable. The effect of the independent variable on lifespan, or the dependent variable. Okay, so our title is the effect of the independent variable on the dependent variable. If you recall from our lab report lecture, the title of your lab report is almost identical to the title of your graph, or some of your graphs. Okay, we see our axes labeled. All right, our independent variable and our dependent variable. We see units. All right, packs per day and years. We see our axes scaled and scaled evenly. You'll notice that we go by intervals of 10 on the y-axis. All right, and that stays consistent with intervals of 10. And we see intervals of 1 on the x-axis. We see data plotted. Presumably, I had data to plot and I've plotted it from a data table or from some kind of quantitative measurement. And finally, you'll see underneath the graph, I call this graph Figure 1, and I actually provide a caption that interprets the graph for a reader. It says, this graph suggests that as a person consumes more cigarettes per day, his lifespan progressively decreases by several years. That is exactly what this graph is trying to display, and I've written it explicitly. This is a quality graph. Take notes, please. So the next couple slides, I'd like us to take a look at some graphs and to hopefully be able to troubleshoot. That is to say, make changes to the graphs so that they display all of the qualities of a quality graph. So let's take a look. First of all, you should notice that the graphs that we'll be taking a look at in a second, these graphs are the ones that we just previously looked at to show different kinds of graphs. And so we're looking at the line graph here. All right, we're trying to troubleshoot this. And let's take a look. Let's go through some of those qualities. Well, first of all, we do see a title. Notice the title doesn't start with the effect of the independent variable on the dependent variable. But this graph actually doesn't demonstrate that kind of relationship. Okay, so the title is there, and it's a decent title. It is descriptive. We want to see that our axes are labeled, and we see years on the x-axis and minimum wage on the y-axis. We don't have units on years, but in fact, the year is the unit in and of itself. Okay. However, for minimum wage, we should look for units, and probably we're looking at units of US dollars. Okay. Our axes are scaled. Those intervals are scaled evenly. All right, that is to say they move up in a consistent interval by ones on the y-axis or by tens on the x-axis. Presumably this is the correct data that is plotted, and we can see that there is a trend. However, there is no caption describing this trend or describing this graph. That would be preferable. And certainly we don't need a key or legend here. We're only displaying one kind of data. Well, here's a bar graph. Notice first of all that we do have a key and we do have a legend here, and that legend is color coded. And so we see blue as total revenues. This purple or burgundy is total expenses or total spending. And then we see green as profit or loss, the net profit or the net loss. Okay, so let's take a look. We've got a title that's pretty descriptive, that tells us what we're looking at. We don't have a label here. Presumably this is years, okay, or time or duration. We should see some kind of dollar value. Now, notice that on the y-axis, we don't have total revenues, total expenses, or profit loss here because the y-axis displays all of them. But we should see some kind of label like that says money or money gained or some kind of something to that effect, and maybe we should see a US dollar here again. That's a terrible US dollar. Okay, we see data plotted. Again, most of these that I found online don't have captions, but in a lab report they would. All right, so let's move on once again. All right, finally, we're looking at that regression curve. Again, we have a title that sort of describes the data that we're looking at. Again, this would preferably be the effect of height on wingspan. That would be a great title. Granted, they asked that same, more or less, they asked the same thing here in question form, but that's okay. That's a good title. We see axes labeled with units, very good, centimeters and centimeters. We have a good scaled, evenly scaled axis on both axes. We're going by fives or so. Okay. Notice that this ends at 62, but that's all right because we see a regression curve that demonstrates a trend. So we see the data plotted. Okay. And finally, we also see a caption here. We see male and female. Red is male, blue is female, and it gives us a key to look at so we understand the data here. Okay. More or less, this is a very good graph. Except for the title, we've got almost a perfect graph. So what we're going to try to do now is we're going to look back at those very same three graphs that we just looked at, and we're going to try to interpret what they have to say. Okay. Previously, we were just looking at, do they possess the qualities? Do they demonstrate the qualities of a quality graph? But now we want to take a look at that graph, assuming they have those good qualities, and try to interpret what they're trying to tell us, or what conclusions we might draw from the data. And whenever we do draw conclusions, especially when we draw those conclusions in a lab report, I think it's a good idea to try to take the data via the XY axis. What I mean by that is, let's take a look at this XY axis. The X-axis, as we know, are years in this sense. Okay, and so a good way to start out your conclusion is, as years progress, or as years go on, or as time goes on, or that is to say, as we go along the X-axis, what's going on to the data? Well, clearly we see the data moving upward as we move to the right of the X-axis. Okay? As we move to the right, we see the data moving up the Y-axis. Well, what is that Y-axis? It's minimum wage. So we say, as the years progress, all right, as we move rightwards on our X-axis, we see that the minimum wage increases. Okay? And that's a simple conclusion. That's a simple interpretation. But though it is simple, it is precise, it is accurate. As the years go on, minimum wage increases. It might not increase linearly, or not exactly linearly, but it is increasing nearly every year. So, in your conclusion, you would describe that trend, and then you try to explain why that trend may exist. So when we say, as the year progresses, the minimum wage increases, we are describing a trend. We are not yet explaining why it might exist, and that comes afterwards, but we are describing a trend, and that's important. All right, in this graph, again, we're taking a look at total revenues, total expenses or spending, and total profit of a particular cookie shop between 2003 and 2005. Okay. We look at 2003 and 2004, and we look and see that their total revenues are generally the same. Their total expenses, or their total spending, is about the same. And as a result, because revenue minus spending equals profit, their profits are about the same. However, if we look at 2005, we see slight differences. All right, we see slight differences in revenue, a decreased revenue. We see slight increases in expenses, or increased spending. And we see, as a result, if we take revenues minus spending, we get our profit. We get slightly smaller profit. So a conclusion we might say is, in 2005, or rather 2005 saw the cookie shop earning less money, spending more money, and as a result making a profit, or making a smaller profit than in years 2004 or 2003. Right? I have just described what this graph is just trying to tell you. All right, and finally, we're looking at that regression curve once more. And this graph is asking the question, is there a correlation? Is there some relationship between height and wingspan? That is to say, are there any trends that you see? Well, I think we can definitely conclude that there is some trend. So let's try to describe it. All right, again, we'll say as, or rather, we can say as height increases. So I'll write that instead. As height increases, ask yourself, what's going on as height increases? As we move along the x-axis, what's happening along the y-axis? Well, clearly, we see there is some kind of trend going here. So we see as the x-axis moves rightward, we see the y-axis moving upward. So as height increases, what's going on in the y-axis? Well, the wingspan also increases. And we have just described a trend. We might also try to explain why that trend exists later on in our conclusion. But to start our conclusion, or to come up with a solid conclusion, we first need to describe the trend that we see. All right, and so hopefully now we've done a few things. Number one, we have described different qualities of high quality graphs. All right, we've described 6 or 7 of them. We have looked at some examples of very good graphs. We have troubleshot or made improvements to less than perfect graphs. And then finally, we have interpreted those graphs. And so those are skills that we are definitely going to need when we write lab reports, when we take tests, and importantly, when we take that AP exam. Okay, so if you have questions, let me know, and I'll be here to help them. All right, take it easy, guys.